Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science, and in this video we're going to talk about how to classify some partial differential equations. So here, on this first page we're going to classify these three, and then on the second page we're going to do a different type of classification, so we'll talk about this when we get there. But for now, let's look at these three. So here we want to classify the second partial derivative of u with respect to t minus the partial of u with respect to x squared equals 0. So when we look at these three equations here, we're going to look at three things. One is linearity versus nonlinearity. Another one is homogeneous versus inhomogeneous. And then finally, we're going to look at the order of the equation. So first of all, this first equation here is nonlinear because of this squared here. So in order for a PDE to be linear, everything has to be a linear function of u and its derivatives. Okay, so this is not a linear function of the partial of u with respect to x because we have the squared. So this equation is nonlinear. Oops. So nonlinear. And what about the order? Well, the order is the highest order derivative that appears. Here's a first order derivative, and then here's a second order partial derivative. So this is a second order equation. Okay, now finally, what about homogeneous versus inhomogeneous? Well, because we have blah 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 equals 0, we have a homogeneous equation. A homogeneous equation. Okay, so that's it for that equation. How about this one here? The partial of, or let's just say u sub xy plus u sub xyz equals x squared times the sine of y. So first of all, this might look nonlinear because of this, but it's actually linear because remember, to be linear, you have to be a linear function of u and its derivatives. Well, this is just x squared times sine of y, so there's no u over here, so that doesn't affect anything. This is certainly linear in uxy. This is linear in uxyz. So this entire equation is linear. Now, if we had x squared sine of y times, let's say, u squared, then yeah, because of the u squared, that would make everything nonlinear. But we don't have that, we just have this. So this is a linear equation. Now how about the order? Remember, the order is the highest order derivative that appears. Here's a second order derivative. Here's a third order derivative. So this is a third order equation. And then finally, because we have this equaling some function of the variables that's not 0, so not always 0, I should say. So this is not always 0, so it's inhomogeneous because we have x squared sine of y instead of 0. So this is inhomogeneous, or maybe non-homogeneous if you prefer. Okay, so finally, u sub t plus u sub x equals tx. So again, this is linear because this doesn't involve u or its derivatives at all, and this is clearly linear because it's just a first order partial derivative, both of those. So this is linear. And again, it's first order because there are only two derivatives here, and both of them are first order. So the entire equation is first order. And finally, this is also inhomogeneous because instead of 0, we have t times x. So this is in or non-homogeneous. Okay, so that's it for these three equations here. Now let's move on to classifying these. So here we're going to do a little bit of a different classification. These are both second order linear equations. Okay, so what we have here is 2u sub xx plus 3u sub xt minus u sub tt plus u sub x minus 7u sub t equals 0, and then minus u sub xx plus 4u sub yy plus 16u sub x minus u equals 3. Now what we want to do is classify these as either parabolic, elliptic, or hyperbolic. That's how we want to classify these. So how do we do that? Well, in general, if we have auxx plus buxy, that's a b, plus cuyy plus dux plus e times u sub y plus f times u plus g equals 0. Now the only thing that actually really matters is a, b, and c. So what we want to do is look at this expression here, b squared minus 4ac. All right, now if this expression equals 0, then the equation is parabolic. If b squared minus 4ac is less than 0, then the equation is elliptic. Let's go ahead and fix that. The equation is elliptic. And finally, if b squared minus 4ac is greater than 0, the equation is hyperbolic. All right, and there are some various properties that are associated with each of these specific types of second-order linear PDEs, and that's we don't want to talk about those too much in this video. We're just going to talk about how to classify the equations. So in order to classify these, we just have to identify a, b, and c. Well, here, a is the one on u sub xx, so a is 2 in this case. B is the one on the mixed partial, b u sub xy. So notice here we have t instead of y. That's totally fine. It does not matter at all. We don't have to have these exact variables x and y. We can have any two variables. As long as we have two of them, then this classification will make sense. So b equals 3 for us, and then finally c equals -1, because this is just short for -1. Now you might be wondering, well, hey, can't a be -1 and c be 2? And yeah, that's totally fine. It actually won't change a thing, because that'll pretty much just swap a and c around. But this expression is symmetric in a and c, meaning it doesn't matter which one's a and which one's c, because the result is actually going to be the same. You're essentially just changing the order in which you multiply them, which changes nothing. So let's go ahead and evaluate b squared minus 4ac. b squared minus 4ac equals, well, that's 3 squared minus 4 times 2 times -1, which is 9. So minus 4 times 2 is -8, and then times -1 gives us +8. So this is 9 plus 8 equals 17, which is positive. And remember, if the expression is positive, we have a hyperbolic equation. So this is hyperbolic. Okay, so that's a hyperbolic equation. Now, how about this one here? So for the second equation, we have a equals -1, because minus u sub xx is short for -1 times u sub xx. There is no mixed partial term, notice that, so b is actually 0. And then finally c is just 4, okay, 4 u sub yy. So then we have b squared minus 4ac equals 0 minus 4 times -1 times 4. So this is 0 plus 4 times 4, which is 16, which is positive. So this one is also hyperbolic. So we ended up having two hyperbolic equations here. All right, so this has been an example of classifying partial differential equations. I hope you found this video helpful, and thank you for watching.